something now.
Today I will teach you how we can find inverse of matrices 2 by 2. So there are three methods here, which are the first one is you need to solve any equation of matrices given until you got 2 by 2 matrices, and then you need to find the determinant by using the formula AD minus BC, and then you solve the matrices given, use this formula where A inverse is equal to 1 over determinant A times with adjoint A. So we move to the example 1, which it is given that A matrices is 3, 5, -7 and 2, and then you need to find A inverse. So the first one would be you need to find the determinant, since it is just need you to find A inverse. So the determinant would be like this: A times D minus B times C. So 3 times 2 minus -7 times 5, where AD minus BC is equal to 41. So here the determinant you got 41, and for the adjoint A you just can find like this, where you just need to interchange between 3, 2, -7 and 5. So for the adjoint A, it would be like, for 3 and 2 you need to exchange their position. So it would be like 2 here and 3 here, and then -7 here and 5 here. You need to times them with -1. Therefore you will got 7 and -5 here. So yeah, it is adjoint A. So after that you just insert into the formula, and then you find the A inverse, where 2 divided by 41 you got 2 over 41, and then until you got 3 over 41. So there's the last. So for the second example is, it is given matrices A and matrices B, but you need to find AB inverse. Therefore you need to find AB first. So how you can find AB? You just need to times both of the matrices, and then you got this. After that you find its determinant, where 31 times by 32 minus 49 times by 14. So you will got -4, and then adjoint A, like I just said just now, you just need to interchange between 31 here and 32 here. So it will be 22 at the top and 31 at the bottom, and then for the 49 and -14 you just need to times them with -1. Therefore you got this adjoint AB, and then you just need to solve them by dividing each of the component by -4. Here you got the answer. So yeah, that's all.
Alright, so hi, we're moving on to the second part about how to find the inverse metric by using the adjoint method. So I will be explaining detail on 3 by 3 matrix. So as you can see over here are the formula that I already stated, where I will be used in my explanation today. So here are the given sample question. For metric A is 2, -5, 1, -3, 0, 1, 2, 5, -4. So find A inverse. So first thing first, you need to find the minor. So minor is actually symbolized as M, and it's required to number over here. So first number is actually referred to the row, and the second number is referred to the column. So how you want to list all of this is basically you need to write M, M, M based on your matrix. So today is I will be explaining on 3 by 3 matrix. So 3 and 3. Alright, so and then you need to put, for the first number is row. So for the first row you need to label as 1 1 1. For the second row is 2 2 2, and the third row is 3 3 3. So for the column it will be constant 1 2 3 for every row. 1 2 3 1 2 3 1 2 3. So done. You already done this thing. Now you need to find the value of the minor. So how does it actually work? So as you guys can see over here, M11 is actually mean one row and one column, first row and first column. So you just left with this number, which will be your minor. So you need to find the exact value by using the knowledge that we already used when we are in form 5, where you need to times A with D and minus with C times B. So you will get the exact value. Same goes for the other minor. Alright, secondly, you need to find the cofactor. So these are actually the formula to find cofactor, where this actually mean for the minor that we already find earlier, and I is actually mean row, J is referred to the column. So for instance, for M12, the upper number here will be 1 plus 2. Alright, row and column. So as simple as that. And then you just multiple with the cofactor that we already find earlier. So you can state it all like this, and then use your calculator and you find your cofactor. Thirdly, you need to find the transpose, or we call it adjoint A, where actually every row will be becoming column. First row will be first column, second row will be second column, third row will be third column. So you already find your adjoint. Last but not least, you need to find the determinant by using this formula. This actually refer to sum. This is actually referred to the original row, and this is actually referred to the cofactor. So how to actually find the determinant is actually you need to choose what row you want to choose in your question. So as we revise back, so these are the question. So which row is much more simpler? It will be second row, right? So I will be choose second row in my calculation, since it have 0 value, so it will make my calculation more easier. Alright, and secondly, you need to listed the second row for cofactor also. -15, -10, and -20. And then you multiply with every one of it and sum it all to get your determinant. Alright, and lastly, you can find the inverse by using this formula: 1 over determinant times the adjoint A. So you put the value that we already find earlier and you times with every number here, and you get your inverse metric. As simple as that. So I hope that we are done. Good job. Hope that you guys can use this knowledge to actually benefit the others. Alright?
Oh my god! I made a big mistake now. I shouldn't do it in the first place.
So at the end of this video, I will add a few question exercise for you guys to do at home, and for the answer scam will be add in the description box.
Oh wow, great! I can do it for my own practice. Or how about I share with my friends? It will help them a lot.